Well, it's Tuesday night, not Monday night, not our normal time, but welcome. Hello, Claudia. How are you?
Hello, Wayne. I'm very well, thank you. And you?
Doing good, doing good. Have to say, fall is upon us here in the Mountain West. So I think we're going to have a cold winter.
That's too bad. Well,
I think you're going to have a cold winter.
it's actually very hot here at the moment. We
Is
went
it?
out earlier and it was extremely hot, but the leaves are falling off the trees, which is not normal because they're being
Yeah.
burnt. You know,
Yeah.
I wrote about that as well.
Yes. Well, we have a number of your articles pulled up on that.
Mm-hmm.
Earth's going
What?
through a lot of changes, isn't it?
Oh, definitely.
Yeah.
Definitely. And it's not a good thing. These are not good changes. These are all bad changes, bad for our planet and for us.
Yeah, and I'm hearing some stuff, going around that there is potentially, and you don't know what to make of these, but they're saying that there could be a pretty big false flag. I just want to say hello to everyone in the chat room. Thank you, moderators. We're already at 93, Claudia, and growing.
Mm.
So now it's grown
Yeah.
96.
I wouldn't be surprised about the false flag. There are lots of things happening, like the war in Syria seems to be getting serious,
Mm-hmm.
and that could lead to Third World War.
Mm-hmm.
We know it's not a real Third World War. The war is not actually between countries. Russia and United States are actually working together to establish the New World Order. The war is against us, the
Yes.
population of the world.
Yes. Yes. And, the more I study, the more research that we all do, boy, you can't help but just come away with some inevitable conclusions. That's the best way I know how to say it.
Yes.
Well, I have some pictures that I wanted us to look at, Claudia, because I always enjoy having you take a look at them as well.
Yes.
So give me 1 second. So how was your week, by the way? We didn't get to do this last night, and it was my fault, not Claudia's. I was actually at the airport, so couldn't be
No,
at
it's very understandable. You need to put your wife first.
Oh, yeah, that helps. It makes for a good cohabitation. That's what I say.
Exactly. Yeah.
It's the famous line, gentlemen. If your significant other, your wife, ever asks you if she looks fat in a dress, your proper response is, "Do I look stupid?" So that's all I can say. It's the safest bet, guys. Trust me. Your wife will think you're a freaking genius.
Yeah.
So, well, Claudia, I am going to share. Give me 1 second here, and I'm going to pull up some photos that I have collected, some that I have taken, some that I haven't, some that have been shared, some that have been submitted. So I want to show you, and let me see, I guess I have.
I love looking at pictures.
Well, good. I think these are going to go, because here we go. I've got them pulled up. So can you see that?
Yes.
Ooh. So this is the sun, folks, and I have not done anything to this, but you can see it already, Claudia.
Oh my goodness. It looks a cloud of something there.
Definitely. Yeah, something.
And it's emitting light.
Imagine that. And it's really close to the sun.
And it's really, really close to the sun. Well, I'm not surprised. Someone asked me, well, you don't know anything about what you're saying because you cannot give us positional and tracking data for Planet X and Nibiru. I started writing an article about that, but my response is, well, the positional and tracking data is as follows: the sun's inner and outer corona.
I love that. And, the absurdity of the question itself.
I know.
I mean,
After I showed all these images with these objects in the sun's corona, they come and ask me a question like that.
I don't know. So this was an interesting one. I had someone send this to me. Like a fleet of something, or maybe a big something. I don't know.
Yeah, it looks like a whole lot of objects sticking.
It does, doesn't it?
Yeah, a whole line of them.
A whole line of them. That's what I thought. Here's the one I picked up last week, and it still baffles me as to what this was, Claudia.
It looks like two large bright sources, but this is the type of image that I've just been examining whilst I was writing that article. And remember, we'll go back to that article, but these dark circles with a ring about them, these are actually point sources of light, and they are everywhere in these images.
It's amazing. It's almost like looking at a 3D print. You like, well, I don't see anything there. You start staring at it and you start seeing it. So we know that this was not Mercury. This was the object that was shot out from the sun. I tell you, when I go back and look at that footage, Claudia, I don't know what that was. And I don't know what this is, but I do know enough of photography to know that
like two objects sticking together.
Exactly.
They seem to cluster sometimes. They cluster together.
Yes, and I think I'll pull this up as far as we can go. So there is clearly, and the pixelation, it's just what it is. But there is an object here. I think there's two. I don't think.
I think it's two. Now, don't forget that these are not small objects. These are objects that are larger than the Earth. Because if you look at the size of the sun, and the Earth is 1/100th, the sun is 100 times larger than the Earth. These are actually very large.
Look at this, Claudia. You're right. So if we put this within the core of the sun itself, that's big.
Yeah, those are large objects.
All right. So here was another picture of this taking all the gamma down, taking contrast and saturation out. So we know now that this really was something, and big. Same thing.
Yeah.
We got some more here. We got some. All
right.
I thought you would like this, Claudia. I came across this and I thought of you immediately. Look at this object here.
Oh, it does look kind of spherical. Of course, this looks like a CME starting to happen, progressing. And I've shown lots of times that the CMEs are actually provoked by these objects. As they pull energy from the sun, they provoke the sun into having these explosions.
Exactly.
So we always find one of these objects, well, if they haven't covered it up and manipulated the images, we usually find one of these objects close to where CME occurred.
Exactly. And I'm glad you brought this up, because so often I will hear what people call a coronal cavity, is that is the CME. But this is very clear here. This is a very compact ejection.
That's right.
Well, I thought you would find that interesting.
Very interesting. Yes, it just confirms all the things that I've been saying. Look at that. That looks like another line of objects there.
Yes, and this is the sun.
Yes. And look at all the bright spots. Those are the debris.
Yes.
Lots and lots of debris. Very clear here.
I'm glad you pointed this out, because, this is extreme magnification, but it's, anyway, that one was like, well, what is that? And here, what I did was, as you can see,
wow, yeah, I can see.
There they are.
Yeah, it's a whole lot of objects connecting to each other in some way.
Yeah.
Very interesting.
I'll pull out slowly. Very odd.
It's how they cluster is very interesting.
So this is Mercury. And Claudia, I wanted to talk about how the Birkeland current is so obvious here. In fact, I took it in the invert, and there you can actually see it. it seems like all of our cameras out there, and I'm talking stereo, SETI, SDO, when they catch our planets, there is a current that is apparently very visible.
Yeah, I'm not sure what actually causes that. It's something.
That's what I'm asking. I don't know what this is.
Because I don't see them. I don't see these. What detector was this?
This is SOHO.
Stereo. SOHO.
Yes. I believe.
Yeah, I'm not sure. You know, I've just figured out the diffraction.
So this is the picture right off of the
in the telescopes, in the chronograph telescopes. So this is SOHO. Is this the chronograph? This is not a chronograph. What is this visible light?
Visible light. I think it's in 197 angstroms. So I just found it very odd that it's visible. And
you say 197.
I think, don't quote me on that. I'll pull it up on the website. But anyway, it's just very odd that when we get the Mercury crossing of the sun, that this came out.
Yeah, I'm not sure that you actually are supposed to get that line here. I've seen lots of images of Mercury traversing the sun, and I didn't see that line.
Yeah, and you really get up
strange.
here. Look at that.
That is very strange.
And you can see it emanating from the poles. This is actually off just a little bit, but anyway,
the line should actually run right through the planet. I'm not sure that, if it's an optical effect, it shouldn't start at the pole. It should
go all the way through.
Yeah.
So
I'm not sure if that's the case here.
And here, I'll pull it up here so you can even see it more. It does not go, you can see it actually emanating.
Yeah, that looks like a manipulated image. It doesn't look real.
Well, I pulled it right off it, and I'll send you the link, unless they doctored it up. And don't ask me what these
I think they're doctoring a lot of things, Wayne. To tell you the truth, I reached the conclusion that a lot of the images that we are being fed from these spacecraft are most likely old images, because the sun, I think, is in a much worse state than these images suggest.
Might be.
I base that on the fact that the sun was dark for 3 hours when the simulator failed over Russia. If the sun was dark during those 3 hours, I think it's dark most of the time, if not almost all the time.
Well, there's enough of that happening.
I mean, we don't see that happening in the satellite images, the solar observatory images that they are giving us. We don't see the sun going dark for 3 hours, do we?
I've actually caught it on SETI. That it's very clearly oscillating in brightness.
Yes, I know, but not staying dark for 3 hours.
No, I have not seen that.
That's why I think these images we're being fed are from years ago.
So this, Claudia, is a UFO that was sent in by a subscriber. And I really was fascinating with this because this object, this is the original. You can see whatever this is, and it got my attention.
Strange.
Oh, it gets better. I really went in and, for instance, I started working in Photoshop and stripping out the layers and enhancing to get an idea of what this object is. And I can tell you it's something.
I would say it's a projector. It seems to be projecting something downwards.
It does. It definitely does. And it gets more interesting as you dig deeper. So here is basically what we call a color neutralization. So we can actually see what's going on. There is something happening here, Claudia.
Yeah, it's rectangular shaped.
Yeah, and here,
and it's definitely shining something downwards. I would say it's a holographic projector. device.
Very interesting.
It's very interesting.
And it's still, and then
Look at
here,
that.
this, folks, is what happens when you begin to do into the mid-level. Look at this.
Wow.
This is something, and now you can really see that this is emanating from this object all the way down, Claudia. Look at that.
Yeah, well, there must be lots of these holographic projectors in the atmosphere, because I don't think we're seeing the real moon. We're seeing the moon simulated, the planets are being simulated.
And look at this one. Here's
everything in the sky nowadays is being.
It almost seems that way, doesn't it?
Yeah.
And look at here. So this one.
Look at that.
This is the one that really I thought was the real.
You can actually see into it.
Yes, you can. And look at this. Very obvious. It's coming from this object. And
almost like it's transparent.
That's the weirdest thing about it. It's almost like, yeah, transparency is a good word for that. And whatever the mechanism. So again, I want to thank the viewer that sent this in. Check this out.
Wow, there's definitely something.
There is definitely something there, folks.
Wow.
Let's pull this up so everyone can get a chance to see it. There, well, it's so pulled out I can't even see it. There it is.
There's definitely something circular there.
That's what I thought. People say, am I seeing things? And I went, well, unless we're all seeing things, look at this.
Wow. There's definitely something there.
Yep. Everyone, you folks in Denmark, I know we have a lot of listeners that are over in that area. I did not realize how bad your drought is. We're going to look at this on the actual difference. Claudia, this is all brown. It's been that hot, that dry in Denmark.
Wow, that's amazing.
I mean, it
usually rains quite a lot in that area.
Yeah, it's green. There is yet another object. There we go.
Look at that. Definitely something there. It's blue.
It is. Look at this. And it is something there, folks.
It's blue and it's surrounded by an edge.
Look at that.
That would indicate a lens. You know, whenever I see that halo effect around an object.
Do you think it's a simulator?
I think it's probably one of the devices, one of the simulating devices. Yes.
And there you go. And I went in and I said, well, what is this? Is this a aberration anomaly of the lens? It is not. It is there.
Yeah, it's some kind of device. Blue is very strange, with a lens in front of it. So I think it's one of the simulating devices. There seem to be more and more of them. I've seen several photographs now where there are two suns, a large one and a small one, and both of them are not the real sun.
But this is what I found odd, Claudia. Look what I found hiding. Now, all I did was take out a lot of the glare. There is a craft in here, Claudia.
No, I'm not surprised. I think our skies are full of craft.
Yes. And as you can see, it's cloaked.
Yeah, that's what they do. They use clouds as cloaking.
So here it is. Again, I began to, because this is the sun. This is the sun in the picture, which is very odd. But look at this. When I started pulling it into the ultraviolet light, look at that. And then I went, what the heck is that?
Yeah.
But you would never see it.
You see, there are quite a few straight lines there that would seem to indicate that it is a craft.
And look at the effect of this halo here. This is really an odd anomaly. Oh, I didn't even see that. What the heck? Look at
Oh my
that.
goodness. Oh, that was not
Whoa.
cloaked, Wayne. That
Look
one,
at
that
that.
was.
I completely missed this. The cloaked object is right in here, folks.
Uh-huh.
Holy Toledo.
Yes.
Look at that.
Yes, indeed. It looks like a little cylinder.
It does.
Mm.
So the cloaked craft is right in here. You can see it right there. We get
Yeah,
this strange halo effect.
that's the lens. There are lenses everywhere. So that's one of the lenses. They even produce lenses out of the atmosphere itself. They somehow produce an interface by applying some kind, I'm not sure if it's sound technology or electromagnetic, but they actually create interface that vibrates.
There
And
it
it's
is,
made out of the
Claudia.
atmosphere itself. So that's why there are these halos everywhere. These are lenses.
Well,
That's
that's
look
clearly
at
a
that.
object right there.
That is so clear. That's
It is.
amazing, Wayne.
There it is, Claudia.
Wow.
Folks, you're seeing it. And thank you again, the gentleman that sent us these pictures. I did not catch this.
Hmm.
That does kind of make you go, I'll
Yeah,
have a
and Wayne,
similar
notice that just behind it, that cloud just behind it, there's a right angle just above the object.
right in here.
Yeah,
Yeah,
there. You see that right angle? That's a craft. That's
that's what I
close.
thought.
Yeah, that's definitely
Holly, do you think we're seeing a potential mothership with a scout ship? You know, of course, that's
probably. Yeah, yeah.
well, there you go, Claudia. Those were my pictures for the day. I'll close with the one that I think is one of the best UFOs
Mm. Ooh.
right here.
Oh my goodness.
Is it one of ours? Is it extraterrestrial? I don't know, folks, but it's real.
It's definitely real.
Brought to you by those that go, what? All right.
Wow.
So, what'd you think of that?
That was amazing. That was
Yeah,
fun.
I thought that you would enjoy that. I don't know how I'm reading some of the comments in here. Yeah, it's very odd, isn't it? Uh, All right.
What a
So
world we live in.
it is getting very weird.
Mm-hmm.
So I have some articles, Claudia,
Mm-hmm.
that I pulled up first of all, we had this submitted by a viewer that said, could Claudia please explain what happened in California? So unexplained pulling forces pulled two planes down in Tulare County. And what the story is, Claudia,
Mm-hmm.
two pilots, two separate planes, both felt this gravity pull that crashed their airplanes
That's very interesting.
in the same exact area, right above this area. It pulled them both down. You can see one plane crashed into the airport sign and another overturned. The explanation, there isn't an explanation. The pilots who reported a pulling before the planes crashed in separate instances.
Well, it sounds like an artificial gravitational field.
It does, doesn't it?
Yeah, that's what it sounds like. I think the technology does exist to actually cause this to happen to planes, where they don't want them to fly, you actually pull them towards the ground. How they produce these effects is basically gravity is energy.
Mm-hmm.
So what you do, you have to increase the amount of photon energy inside a region. It could be underground, because when you affect all the energy levels, you affect all the energy levels above. So by increasing the energy, it's as if you were at another point on the earth, say within below the crust or something like that can change the energy levels. Or it could be magnetic.
Ah, could be. Could have been an anomaly. I just wanted to show
Yeah,
that.
it could be.
I'll send you the article if you'd like.
Yeah, I'd like to read it.
Okay, I'll send that one to you.
Without having read it,
Yeah.
But
Well,
definitely sounds like an artificial,
it does to me as well, doesn't it?
yeah, gravitational field. Very interesting.
So these next articles are right in the California. The groundwater loss prompts more California land to be sinking. And one of the things that I knew from growing up in Northern California was that in the San Joaquin Valley, they have pumped out so much water in the 30s that it literally dropped the whole valley by over 2 feet.
Wow.
This is still happening, and the ground is continuing to, well, sink.
Yeah. Yeah, well, that's to be expected if they're removing the water out of the ground. Eventually,
Wouldn't that have a pressure on the fault lines?
Yeah.
That's what I was thinking.
Mm.
Here's another one.
Mm.
You folks out there in Las Vegas and downstream from the Colorado, I'll explain this to you, Claudia. In the West, water is very, very precious out here. And the Colorado River, which is fed primarily from Colorado, from the snow melt, well, we're in like a 20-year drought in this area. And you can see where the water was at one time, and it just continues to drop. Wow. And I bring this up only because it's showing a continual pattern that's taking place. Another one, this one I've brought for you.
Planet 9 may exist, but it might be hiding behind Neptune.
So,
yeah.
Dr. Albers.
Look at the farthest reaches of the solar system. Look 60 light years away. Never look at the sun. Never look at the sun.
Yes. I find this odd because I think they're feeding us information. They're dropping little tidbits like, guys, there really is something out there.
Yeah, well, there is, but they all coming in and settling in the sun's corona. I mean, that's what Dr. Robert Harrington went out to find. Something out there. What did he find? He found something coming in. The thing is, he did this in 1981.
Yeah.
But by, I've shown that by 1860, they were here already. They were coming in. He probably found some more of these objects coming in. They were probably coming in from all directions because the system is so huge that it just encompassed the whole solar system.
Well, here's what I found interesting. 6 known objects in the Kuiper Belt, all of which have elliptical orbits that point in the same direction. The orbits of the objects are all tilted the same way, 30 degrees downward. Mm-hmm. Computer simulations that show that there are more objects tilted with respect to the solar plane. Planet 9 could be responsible for the tilt of the planets in our solar system. The plane of the planet's orbits is tilted about 6 degrees compared to the sun's equator. Some objects from the Kuiper Belt orbit in the opposite direction from everything else in the solar system. So would you say that they're trying to prepare us for this?
Yeah, well, they know that people are questioning. The thing is, these objects are not in the plane of the solar system because they're newly acquired objects. What it shows is that they are new objects entering the solar system all the time. A lot of them have stayed out there. What are they? They could have been part of the Planet X system. I mean, we know that all the planets, especially Saturn and Jupiter, have gained a whole lot of moons. Mm-hmm. That means there are objects coming in all the time. That's where the moons are coming from. But they don't talk about that. They will always say, no, these objects have always been there.
Speaking of
they're coming in, they knew.
The outer planets, something's going on with Saturn.
Yes.
This is
heating up. It's more energetic because the stellar cores are pulling energy out of it just like they are doing with the Earth. That's why our ionosphere is more charged. That's why Saturn's atmosphere is more charged. That's why we get increased aurora at its pole.
Isn't it interesting, too, the golden light here in this band? I still marvel at this.
I believe that Saturn is emitting X-rays from the equator now. So that's why it's getting more and more visible, because don't forget, Saturn is a star. The stellar cores are energizing it. It's not that it is generating more energy, but it's still generating energy out of its own core, because Saturn still has energy in it. But the stellar cores are drawing the energy out, so Saturn's generating more energy than it was before. That's why it heats up. This is why the boundary of our solar system, I mean, there's lots of data that shows that our solar system just outside it is hotter. It's hotter because there's more energy coming from the inside of the sun and heating up the whole of the solar system, including the outer edge of the solar system. It's all coming from the interior, and it's coming out of the objects because of the stellar cores drawing the energy out.
I'm so glad we have you. I love this. By the way, here's the solar eruptions may not all have the slinky-like shapes after all. That was that picture I showed you.
Yes.
And you know what this shows me is that they're continuing to learn about our sun. People get all wrapped around the axle because they say, well, that can't be because, and I'm going, well, what do you mean? Where do you think that we got all this knowledge, that we know everything now about the sun? It's a little bit older than us, right?
Yeah, to tell you the truth, I think that physics and astronomy got hijacked by the turn of the 20th century. In other words, they stopped allowing discoveries that would lead us to understand what's going on in the solar system right now, because by then they knew that something was up. And then they decided, even then, or someone did, they didn't want the population of this planet to know what was going on, what was going to happen to the sun and our planet.
I think you are so spot on. Claudia, I found this real interesting. Apparently in Arizona, they are having so many earth fissures, what they're calling ground subsidence, that now, and those of you who live in Arizona can probably address this better than we can, but now you get a report from the Arizona Geological Survey.
Wow.
It's getting bad, Claudia.
Yeah, a bit. It will get a lot worse as time goes by. Basically, the surface of the Earth is going to break up.
And this map is representative of that. The darker the color, the closer to the surface, the darker the color, the deeper down.
Wow.
But we're seeing activity, seismic activity across the map. Very weird. I told you about Denmark, right?
Yeah.
This is what it normally looked like, Claudia.
Uh-huh.
This is what it looks like now.
Wow. It looks like a desert.
June 6th, 2018, July 27th, 2018.
It almost looks like the Sahara.
It does, doesn't it? And it changed that quick. I mean, we live out here in what's technically called the high desert plains. That is quick evaporation, and I think you could address this. I contribute this to increase ultraviolet.
Yeah, the sun simulators are heating up the surface. I've noticed that they've powered them to high power levels, much more than they need to. And that may be because for several reasons. First of all, they want to heat up the atmosphere to produce normal temperatures for summer when the sun's not working. But they overdoing it. Is it possible that I know they are manipulating the weather. I don't think we get natural weather anymore. The weather is being manipulated. And they're not doing it so that you get weather that, normal. They usually get it so we get severe weather, so it's destructive. So
this is destructive, I would say. I mean, it's got to affect I'm sure they grow vegetables there.
Yes, I'm not sure this has to do with Planet X. The stellar cores are heating up our ionosphere and would produce more severe storms and lightning. But this is due to the manipulation that they're doing with our atmosphere, the weather manipulation. Where they're making the simulators too hot. They have steam machines to produce steam. That they've been doing for over 100 years.
Yep.
So we're not getting, we used to get the heating up of our equator by the sun. Of course, without the sun, we're not going to get that. That's why the Earth seems to be warming up more at the poles than anywhere else.
Speaking of which,
the sun's not working, we're not going to get this difference between the equator and the poles. And, the weather systems of a planet are not easy to manipulate. So it's getting extremely chaotic. I think.
This is showing, again, what's happening to the Arctic area. Look at where it's almost like it's getting heating up and it's sliding over the edge.
Yeah.
That's what it reminds me. That's just what I look. And I just kind of close out this little part. This is a very cool map. It shows you all the seismic faults, cross faults right here in the United States.
Wow.
So anyway, Claudia, there you go. That was my little show and tell for today. I hope everyone enjoyed that. I think it just goes to show, and I had a lot more. More fissures are opening up around the world.
Yes.
More of these sinkholes, and I'm talking not just what I would get used to as a sinkhole. I'm big ones. I mean, buildings are falling down and they can't find them.
Mm-hmm.
So, Claudia, I have some of your white papers ready to go, and I thought that if you might, we have a number of them. We have a chronograph, the moon as a hologram. Which one would you like to go with?
Well, we can start with this one.
Okay.
Planet X approaches Earth geomagnetic storm of August 26. So I go through the graphs. I don't use the simulations because I don't like the simulations because I don't think it's very difficult to interpret them because they always change the colors for each frame. So I like to use the graphs. So we had a geomagnetic storm that was actually a surprise that hit on 26th of August. Now, just before the storm, and this was a storm, I mean, we went up to KP7, so that was a G3. Just before then, there was actually a small CME that hardly had any effect. So if you scroll down a little bit, we can actually see, you see the KP index there goes on the 25th, goes up from 1 to 2.
Right here.
That was the CME.
Oh, okay.
That was the CME. It hardly had any effect on the magnetosphere. And then suddenly, towards the end of the 26th, the KP index starts rising. It goes up to 7. So that's a strong geomagnetic storm. And then it stayed up for days until the 28th. I mean, it went up and down, but we kept on having space weather conditions, So then so we can go down, and I started analyzing what was going on. So I just show the KP indexes. It means strong. I looked at the corona magnetogram. It also showed the greens, the green bars, as you can see. That was the CME. Then towards and then it goes red towards the end of the 25th. That's the beginning of this strange thing that started happening. And the corona magnetogram basically measures magnetic effects. So it's the magnetic effects of whatever's coming in on the Earth's magnetic field. You see, according to corona, it went right up to 9. That's strongest possible geomagnetic storm. So it shows a very strong magnetic disturbance on the Earth's magnetic field. And you can see that it stayed unstable after that into the 27th.
It did.
Yeah.
And then we had, okay.
So, okay, if you scroll down a little bit, then I explain what actually occurred. And you can see it was not solar wind density, because what we had, it only went up to 25 on the 25th. That's when we had that small CME that hardly did anything. And on the 26th, it only went slightly above that. So that it was not solar wind density that was causing this. And in the next graph, I show that it wasn't velocity either. Because they said, oh, after the 26th, they said it was the right thing. As you can see, the velocity only goes up to 650. Now, right. I have articles showing that it's not fast solar wind. In order to have fast solar wind, it has to move at a speed of 800 kilometers per second or faster. And the solar wind never went much above 650. And that was not even on, well, the 26th, it was definitely a magnetic effect. On the 27th, they started saying, oh, it's fast solar wind coming from a coronal hole. There's no way, because the solar wind was never fast enough to be fast solar wind.
Interesting. And I think we have suspected that there was something else pushing this. Yeah.
Well, so here you see that it's what happened on the 26th started happening on the 25th is the Z component of the magnetic field went below -10. When that happens, you have a south-facing magnetic field. You can see it in the diagram below. You see it went to -15 there. The Z component, so you would have a south-facing magnetic field, and what it does is it connects with the magnetic field at the magnetopore's position in front of the Earth, and it opens a hole in it and allows solar particles in. So that's what happened at the end of the 25th and the 26th. It shows that something with a very high magnetic field approached Earth. And then on the after that, on the 27th, something else was happening. It wasn't the magnetic field anymore, because it wasn't that, it didn't go below -10. Once it doesn't go below -10, we don't have that. But what it shows is, and that there was an object that came in after the CME. So the CME impacted a small CME. There was a stellar core behind it.
Interesting.
And these objects have very high magnetic fields. And I think the A spacecraft, because it doesn't show as high a fluctuation as the corona magnetogram showed, means that it didn't actually, it was not in all the solar wind that was going past the A spacecraft or the Discover spacecraft. It was an object that missed the spacecraft. And so the magnetic field was contained inside the object, and it was affecting the solar wind around it. But as you move further away from the object, the effect is not as large. So it shows that it was a compact, solid object with a very high magnetic field that came in after the CME. And what else came in? What else was affecting the Earth? If it was a stellar core, it most likely went back to the sun. But what's left behind is the debris that it brings with it. And the debris would come in and start affecting the Earth's magnetosphere, the Earth's atmosphere. It kept on coming in on the 27th and the 28th. And this debris is immersed in coronal plasma. So it's detected as if it's solar wind particles, but it acts has different effects. It absorbs energy from the Earth. It ionizes our ionosphere because it pulls energy out from the core of the Earth. And the interaction causes heating and electric fields and currents. That's why our ionosphere is so hot.
Yes, and that we have to do
And
a
you
show
can
on
show
plasma.
that's why I show that image, because you can see that these objects always come out of the sun, away from the sun, or ejected from the sun whenever there's a CME. They actually provoke the CME. The CME then moves away from the sun, and they move away from the sun as well with the CME material. And that's why the stellar core came in just behind the CME.
And that's why it always appears to be, I call it a ghosting effect.
Uh-huh.
I really do. I mean, can we go to the coronagraph on, let's see, which one do I want to, I think this is the one.
Yeah.
Yeah.
This was fascinating for me. You actually sent me the first of these images, and I started looking into them. So first of all, we know we have stellar cores in the sun's corona. There it is, solid object. It's striped. The stripes are curved because they follow the contours of a spherical object. So we clearly have evidence of a spherical object. This object, by the way, is about 4 times the size of the Earth. It's not a little object. It is small as stellar cores go, because some are a lot larger than the sun. But
look at that.
It's not small in comparison with the Earth. It's 4 times larger than the Earth.
That's big.
These are stars.
Big. Okay. Look at that. Wow.
Yeah, and these are actually brown dwarfs. I show in some other articles, that's why they are striped. This is characteristic of a brown dwarf. When it loses the ability to emit light like it once did before, it becomes obvious that in its atmosphere, it has different bands, and they end up being of different colors.
Okay.
So Jupiter is actually, I think, going into the stellar core phase. It's a star going into the stellar core phase. So it's turning into a brown dwarf.
Well, isn't it the theory that the outer planets were really just kind of captured by our sun? Or
it's possible. It's very possible.
So you just tell me when you go.
All right. Okay. So let's look at this. First of all, we have what looks like a ring pattern right next to the sun. You see that little ring pattern there?
Well, excuse me. Give me folks here. I want to.
Okay. There so I looked at this object here, which you noticed first. You sent me the gray ones, which are polarized.
Yep.
I looked at the full images because I think there's more depth to them. And as you can see, there's a ring structure there. When I looked at that, I thought, what? Newton's rings? Well, all physicists know what Newton's rings are, because you do an experiment with Newton's rings, whenever you study physics. That's diffraction effects. So I thought, oh my goodness, diffraction effects. Well, it's a telescope. It has a lens. Whenever you have a lens, you have a small eyepiece lens, you're going to have diffraction effects, because light has to curve around, because it's a wave. So you're going to get, there's nothing you can do. You're always going to get diffraction effects. But the number of rings shows that they've actually defocused the telescope in order so that you get more of a ring pattern there.
And I'm going to, there we go.
So it means, it means that a light source turns into a ring pattern.
And that's so distinct.
Diffraction effects. So that's a light source.
So this is what we're seeing.
Yeah.
Okay.
Now, then I wanted to make sure that this is not a star. Now, it's not likely that we're going to see a star through the sun's corona. They're just not bright enough. The sun's corona is very bright. Just think about it. You're looking at the sun. How likely are you to see a star right next to the sun? It's about impossible.
I would say.
The brilliance of the sun covered by the occulter, the corona is still extremely bright. You're not going to see stars. So it's not likely that it's a star. But I wanted to make sure. But then I show what the diffraction effects are. So that's what the diffraction effect of a star. So on the left, you just see a little ring around it. Okay, that's when the telescope's focused. When the telescope is defocused, So they've done this on purpose. Then you get the large ring pattern. You can also get the different effects that I show on the right. And that is if the mirrors are not aligned properly. And that's to do with collimation. You can get different effects. I'm sure you will. I think we've seen effects like this in some of the coronagraph images. It looks like a ring pattern, a semicircle. That's what it is. It's uncollimated telescope. But what we have here is a defocused telescope showing us there's a light source there. That's why there's the large ring pattern. And I think they defocus it on purpose so we don't see the objects. But definitely we have a light source there. And then we can have other effects, and that is atmospheric turbulence. Of course, this telescope is on the surface of the Earth, so the atmosphere will affect it. So this is what it looks like. If it's focused, you just get a distorted ring pattern around it. If it's defocused, you get a large ring pattern, but it's distorted as well. And then you can get even worse effects as shown on the right-hand side, where the source of light, you see in the middle, you see what that source of light would actually look like. But through a telescope that is defocused, it's not collimated properly, and is most likely having atmospheric turbulence effects, you get a dark circle surrounded by a ring pattern that is distorted. Look at that. And when I saw that, I said, oh my goodness, I have seen lots of that in the core 2 images. I'm writing an article about that. But here I'm sticking with these images from the Hawaii Observatory. And as you can see, this object, when we first saw that image, it was from 1701. This one is from 2042. The object is still right there in the same position 3 hours and 40 minutes later. Now, no object will stay with the sun, because don't forget the Earth is rotating, and as the Earth rotates, the telescope will track the sun, so it's looking at the sun. But if it was a background object or a planet, it would never stay with the sun. You would move with respect to the sun. So the fact that it stays with the sun means it's bound to the sun. It's moving with the sun. It's a stellar core. And not only does it stay there, 7 hours after we first saw it there, it's still there. It's nearly 7 hours. Then it has moved. Now, in the first one, it hasn't moved at all. It's exactly in the same position. And then if you compare the 2040 image with, that's the 1701 and the 2040 image, hasn't moved at all. It's right there, almost, because that's very close to the photosphere. So this object is in the inner corona, very close to the surface of the sun. Then if we compare, this is the 2040 image and the 2356, something like that. It has moved slightly. The object has moved slightly upwards. So it's starting to move. And then we look at the image at 149, and you can see the object's not there, but we see 2 objects above the sun. It may be one of them. I am not sure, because the signature is a little different. It could be different just because the brightness is different, but it could be one of those 2. In other words, it would have moved up, but I cannot be sure it's the same object. Either way, the object has now moved, because it was there for 7 hours. It's not there anymore. Then I looked at some images from March, and I started looking carefully at what I saw. As you can see on the right-hand side of the sun, there's an object there. Oh no, these are the first, sorry, these are still the two from July 6th and July 7th. I just show how they've moved and what they look like. I just compare the two there. Then I look at March the 6th images, and you can see on the right-hand side there are two objects. And then a little later there are three. And I actually measure how the objects have moved. And initially they haven't moved at all, but a third object appeared. And then the third object seems to be moving a little closer to the sun. I think all of them move closer to the sun first. I actually measure how far they've moved. So the earlier image is the above image, and the second image is below. It's from 2115. Now move up a little bit. And if you compare the images, you can see that all the objects have moved closer to the sun, slightly closer to the sun. You know, I use those red grid lines to show that they've moved closer. The center of the objects have moved from that side to that side of the grid lines. So they move closer to the sun. Then if we look lower down, you can see they now moved, later on, they move away from the sun. Now, you never expect, okay, some people will say, oh, it was a planet. It was a planet. And the planets, but wait a minute, planets don't move closer to the sun and then a few hours later away from the sun. They don't move like that. Only stellar cores move like that. So I did, you know, I specifically showed these have to be stellar cores moving in the sun's corona. Wayne, your microphone is off.
Well, there you go. That's why you don't step on the teacher. This is fascinating.
Yeah, this was fascinating.
Just fascinating, Claudia. I mean, and you know, folks, you should go and look at these websites. You can see it for yourself. This is just mind-blowing.
Yeah, and then lots more objects there because there are a couple that look like dark circles surrounded by a ring pattern,
right here,
like I showed. There are lots of objects there.
Look at this.
They obviously defocus the telescope so we would not notice them.
Bastards. Look at here. That's exactly what you were showing here.
Yeah.
Yeah. Wow. Yeah. Okay, I'm going to pull out of this for a second and see how everyone's doing in the chat room. This, Claudia, this is
fascinating.
It's significant.
It is significant.
333. 300.
Yeah, it's 333. Yes.
Yeah. I was just saying that. 333. Number, huh? Yeah, I went okay.
Well, thank you, Wayne, for sending me that image because it started me on a journey.
I like doing that because when you go on a journey, that means all the rest of us get to go on a journey.
Yes, a journey of discovery.
Yes.
Discovering the truth.
And that's where free thinking comes in, because if I like how you said it, that, you know, science was hijacked, and it's a shame that free thinkers are not elevated higher in the institutions of higher learning.
Yeah, that's right. You know, I think they knew like I said, they knew these objects were here by 1860, or someone did. And they started figuring out what they were going to do, or the powers that be, in order to stop people from realizing what was going on. And so they started making their plans. And one of the things they did was start hijacking education and research so that whatever would lead to understanding what was going on with the earth and the sun was blocked. So that people, nowadays, if you tell people, oh, these objects are in the sun's corona, they will say, but that's impossible because of gravity. Because they've all been taught how gravity is supposed to work, which is wrong. But it's like it's the minds have been blocked from understanding these things through the educational system, through the research, through the fact that they put the peer review system in place to block certain things from getting into the research and from being published. All this was done on purpose to stop us knowing what was going on. Now, I'm sure the astronomers that look at this coronagraph and know a little bit about diffraction know what they were looking at, because they use these images to calculate the brightness of the corona. I'm sure they know what they're looking at, but do you think, what do? They close their eyes and don't mention it.
Yes, that's a fact. And Claudia, while you're doing that, I actually went to the Corona, the HAO website, and was actually going to pull up an image, but it's taken a long time. There we go. So,
and they're very close to you. They're in Colorado, the HAO.
Yes, they are. In fact, what most people don't realize is that when they start harping on me, the Naval Observatory is just a little bit north of me. Oh. They're the ones that take care of SETI.
Oh.
Yes. And so this is the K-Core. And this is the website, folks. And you can see our object is not there, but our dark objects are, Claudia.
No, they are there.
They are there. And folks, this is a fascinating site if you really want to study.
There's something there at the bottom. Look at that. It just showed up for a moment. One of these
right there. Look at that.
There it is. You see, they're moving in and they're moving all over the place in the sun's corona.
Oh, look at this one right here.
Yeah, that's the one. It shows
Look at that. Look at that. Yeah. Yeah. Folks, this is why we come on Monday nights, i.e. Tuesday look at this.
Yeah, now we know what they are. These are actually light sources there.
Look at that. Fascinating. What a bonus.
Of course.
I mean, wow. That's all I can say is wow. Can we say wow?
Well, of course.
Wow. It's wow, folks. Oh, Claudia, another hour has come and gone. I mean, wow. See, that's what I'm talking about. Wow. It is just fascinating what we have the privilege of learning from such a great mind like yours, Claudia. It's, I'm telling you, we walk away at least a little smarter.
Yeah, I never thought of myself as a great physicist or anything. I always thought of myself as a teacher. I wanted to teach my students the truth and teach them to think for themselves. But in the process of trying to teach them to think for themselves, I think I taught myself to think for myself too.
Oh boy! Now you see, now the philosopher is teacher, teach thyself. Learn what you're saying.
Yeah.
But Claudia, I had this conversation over the weekend with someone about you. And I said, the great thing about Dr. Albers is this. She is truly a rarity amongst the science community, because here is the exact example that we need to see today of what free thinking will allow you to do. Think out of the box and look at something that people just shrug off, and yet within it is a mystery. And Dr. Albers, is that what you do for us? And
Thank you. That's lovely.
Well, it's a fact, and I can only just speak to what I know. And there's our number again, 333.
333,
so, I think this is great. Well, Dr. Albers, I have your book listed as well. That is on Amazon. Do you have a copy of it right next to you? So,
I actually do. Yeah.
Let's see that. Folks, you really need to get her books. Seriously, folks. I have the privilege that Claudia shares the articles with me, and we only show a very small portion of them. This is an opportunity for you to have what I think is one of the brilliant minds of our age, for an opportunity for you to have it in hardcover. And I'll just finish with this, Claudia, because you see, once it's in book form, as this continues to evolve and as we begin to see it becoming more mainstream, you'll have the evidence that shows where it started from.
Yeah, that's right. And no one can take it away. That I like the printed page.
Yeah.
I started buying myself books again. I arrived here with just 1 or 2 books, but I've started buying books because first of all, I just like holding something in my hand that's not digital. It's actually paper and ink. But no one can, by taking away the internet, taking away your book.
Yes. And I just want to say this, Claudia, again. One of the things that I admire you, because much to my same path in life, there have been times where I've lost everything. And when I think about your journey over here and the fact that something as precious as books, and to those of us who are lovers of books, you know what we mean, for you to have to give that up. And, that's one of the things that I so admire and respect of you. I just, you have
I left everything behind. I left a whole household of furniture and books and
folks.
stuff that, it took me years to gather. I left everything behind.
So let's buy her book. Let's just, I think it would be a great way of supporting what the professor does each Monday night here. And I think it's a great way of supporting you, Claudia.
Yeah, thank you, Wayne. And I must say, your photographs are amazing.
Well, that's my job. It's like, I enjoy producing. So,
yeah.
And
you do a great job. And you're such a wonderful interviewer.
Well,
you just you ask the right questions and you give the person you're interviewing plenty of time to answer, and you're so good at it.
Well, I think I learned the parable at a child. The good Lord gave us 2 ears and 1 mouth. So that tells us everything. If you listen twice as much than you speak, you're going to look like a really smart person.
Yes, that's right.
Well, folks, Claudia, your channel, anything you have? Because I know you put out, I watched a couple of your videos last week. Folks, it's when Dr. Albers is producing her own videos and her papers, I'm literally, many times I'm taking notes. You just present very well, Claudia. So go there,
thank you.
Subscribe, and let's get this out. Folks, we will see you next Monday night, and have yourselves a good week. And Dr. Albers, a privilege as always.
Thank you, Wayne.
We will see. Well, we appreciate you. All right, folks, love yourselves, treat yourself the best. And when you do that, you'll start treating others like you treat yourself. So that's our little thank you all. We appreciate you coming in. It has been a great evening. Thank you. Thank you, Dr. Albers.
Thank you.
And we will see y'all next week. All right. Be good.